Hello, my name is Muhammad Wafi Benzaini and my matrix number is AE160023. So today I would like to brief the introduction for our mobile robotics project. So first of all, solving all the tasks associated with navigation, which is mapping, localization and path planning, are used to develop a complete navigation system. So ignoring any of them would make the autonomous navigation incomplete and not fully autonomous. Additionally, even though they can be described, solved, and can be implemented separately, these tasks are directly related to each other. So next, we move to mapping. So mapping is one of the important process that involved in creating autonomous navigation for mobile robots. So basically, mapping is the process of creating a map that represents the environment in which the robot will operate. So it will create a numerical model of the environment around the robot. So this map will allow the robot to make appropriate decisions and it will avoid the robots from getting damaged. So for the robot to locate itself in the environment, it needs to know how the environment is structured and how current observations relate to previous ones, which are provided in the form of maps. So basically the maps are in form of metric or hybrid. So it will be generated by using characteristics of the structure of the landmarks or any other data from observations and sensors. I think that's all from me. So thank you.
Assalamualaikum. And my name is Ni'am Zaim, metric number CE100028. I'm going to discuss about the localization and path planning. So, localization is process of determining the robot's position or location depends on its environment. Some robot may has its local coordinate system, may have its own coordinate system. So it is also a process of establishing a map coordinate corresponding to its system. So the application of biofilters in this localization process is called Markov assumption or Markov localization. It consists of two-step process, which is prediction step or correction step. This two is called belief. So in determining localization, this prediction belief and correction belief need to multiply to find the correct and accurate position of the robot. There's other method in finding position of the robot. We call Monte Carlo localization. It's a non-parametric approach. It's a particle this probability that counts on particle that representing an approximate robot position. The more particle, uh, like 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 we can see here, the more particle represent, the more belief that have and that position can be true. So the hypothesis is the robot localization is determining depends on the particle concentration. So next is path planning. Path planning is the method that lets the robot know the shortest way to go to the point, which means if a robot want from point A want to go to point B, it should process and know which way is the shortest and lesser obstacle. For this process, path planning process, it requires a map. From a map, robot will calculate and analyze about the pathway that has the least obstacle and has the shortest way uh, to go to the next point. Most common map use is and the most easiest way to uh, do a path planning process is grid map process like we can see here. This is the environment and that a map that consists in squares pixel of arbitrary resolution. So from the robot sensor, it can know the obstacle and it analyze the obstacle and pathway in pixel formation, and it's easier to count and make an analysis in this way. So that's all for me. Thank you.
Assalamualaikum and hi, my name is Aifian. I'm going to discuss two important parts in our project. The first part is methodology and the second part is the simulations of our project. The simulation will be done in Ubuntu. Next, moving on to the methodology. The methodology starts with the display of house layout and also the turtlebot in Gazebo. This can be run by using specific code which we later shown in the simulation. Next, we have to allow the teleoperations of the turtlebot by launching some code in the terminal. After that, we will be also doing manual G-mapping using teleoperation where we control the turtlebot using the keyboard W, A, S, D, and X for front, left and right, reverse, and also stop. After we manage to manually map or the whole layout of the house, we will save the map. And after we save the map, we can use the gazebo, and we can use the G mapping, the map that we have saved earlier, to actually do autonomous navigation using turtlebot 3. In addition, for further information, the model of the turtlebot that we're going to use is turtlebot 3 Burger. Now, moving on to the simulation part. Moving on to the simulation part of this project, we will talk about how autonomous navigation is done in this project. The first item is to actually create a home layout that is a default map available in ROS. First, run this code, source catkin to source it. Next, just export the model. The model we use here is Burger. Turtlebot Burger. 3 Burger. After that, we will launch our map. Okay. You can see this is our home layout map. The next step is to launch mapping process. Okay, the next part is to actually, for the mapping process, in this mapping process, we have to first launch SLAM. This is very important for mapping process. Using the same code, we can actually launch. First, we need to source it. After we source, we need to choose the model of the turtlebot. The turtlebot model that we have choose is Burger. After that, we shall launch SLAM. The SLAM method we use here is G-mapping. You can see that this is our G-mapping map. You can see that it actually mapped the whole area of the layout of the home map. Now, next, moving on to the manual mapping process of the home layout. Moving on to the manual mapping process, where we use keyboard to actually manually run the robot around the layout and save the map. First, we shall source the catkin, and then after that we shall launch our model robot, that is turtlebot 3 model. The model is the Burger type. Next, after that, we can actually launch the turtlebot teleop.launch, where we can control the robot by using the keyboard W, A, S, D, and X. You can see that by pressing repeatedly the letter W in the keyboard, the robot will move much faster and the mapping process will move on. It will take some time. After the process of mapping finish, we can save the map by running a specific code. Okay, now the map I've saved can be saved here at home. Here is the map that we have saved earlier. The next part is to actually launch the map that we have done by actually run back the first code, that is source first. Then after that we can actually launch export the model. After we export the model, we shall launch the navigation. Now we can actually simulate the moving robot by actually using the 2D navigation tools, which is available in the software. By using this, we can set the destination, which allow the turtlebot to move from one point to another point. Now there's some example of simulation can be shown here.
Hi and Assalamualaikum to Dr. Abu Baidah. My name is Anis Afrina binti Muhammad Amruddin. So now I'm going to proceed with the application. So in 2019, the total population of Malaysia is around 32.6 million and has expected number of elderly people aged around 60 years and above is about 10.3% of the total population. Thus, the rising number of elderly people is a concern as more medical staff is required to take care of them. Hence, with autonomous navigation wheelchair robots can strategically solve this issue to assist with mobility throughout their daily life. In both cases, as it aids in human care. Autonomous navigation wheelchair, or is known as Anwar, can be used to navigate around the house, giving the elderly, especially those with movement impairment, to move about. Anwar is giving the chance to the elderly to lead an almost normal life that allows them to move about in their own home without anyone's help. Anwar also is equipped with AI system which can provide the entertainment to elderly by reducing any mental stress that they are having, and even be equipped with the safety protocol that deny access outside without any permission. So, Anwar or autonomous navigation wheelchair robots is safe to use, especially for the elderly. Next, for the conclusion, the basic structure of autonomous navigation robot is mapping, localization, and path planning. Because without each part of the system, the autonomous robot cannot be moved throughout the map environment to locate themselves or to plan path between the position. And with the rising number of elderly people, navigate the task is one of the demanding for the caretakers, especially for the healthcare in the future. To lessen the burden, an autonomous wheelchair navigation system is very helpful because this robot can follow the optimal task to its destination. Because by using SLAM is very suitable to provide a robust algorithm that can do the mapping process accurately. Because with the accurate map, the turtlebot managed to plan a path that does not collide with any obstacles, where the turtlebot had to travel from one point to one point with a path that does not have any obstruction. Hence, SLAM is a good option that can be used in the implementation of the Anwar, because this allows Anwar to smoothly travel in the space of home or care center without any obstruction, as it will lessen the burden of the caretaker or the family members. Thank you.